Assalamu alaikum wa rahmatullah. My name is Mohammed. Today we are going to talk about Eco-Ontology for supporting interoperability in product lifecycle within product sustainability. Outline, background, comparison criteria, comparison of eco-design tools, related work, and finally expected result. Background, there are indicators for products such as functionality, quality, cost, and finally sustainability. The product lifecycle started from the raw material selection, resources, manufacturing, distribution, used, and finally the end of life. Sustainable product related to the three dimensions, which are economic dimensions, environment impacts, social requirement. As you know, the sustainability process related to many inputs and outputs related to the aspects. For example, for the environment, the energy is the input for sustainable process. The output is the carbon footprint. For the economic, the input is cost and the output is revenue. And finally, for the social, the input is impacts and the output the benefit. Comparison criteria. There are some features we will focusing on it in our paper. For example, early design phase, which is supporting decision makers in manufacturing to integrate and advise alternative to concept the environment in early phase of the design process. Store detail information, reuse data, sharing information, semantic interoperability, automatic reasoning, and finally complex revision. In this table, a comparison of eco-design tools, there are many eco-design tools such as checklist, quality function deployment, lifecycle assessment, case-based reasoning, ontology. When you see in this table, for example, the checklist only cover the early design phase. QFD only cover the early design phase and reuse data. About the lifecycle assessment, cover 3 early design phase, reuse data, stored detailed information. About the case-based reasoning, cover the early design phase, reuse data, store data information, and finally the sharing information. So when you focusing on the ontology, will cover all the parameters. For example, the semantic interoperability, the automatic reasoning, the complex knowledge will be covered by ontology for product sustainability. Related work. In this table, you can see the started from the 2002 by other Caballero, developed a life cycle assessment ontology. Moseed 2013 developed a life cycle assessment ontology and life cycle cost ontology. Sheng 2018 developed a social life cycle assessment ontology. Mabhout 2019 developed life cycle assessment, and finally Mar at 2020 developed the life cycle assessment. And when you focus in this table, the product life cycle interoperability and the relation between this product life cycle and LCC and social life cycle assessment, we need to make an integration between them. So the ontology will integrate all of this and facilitate the decision makers to select the best choice for the product, especially in the raw materials and particularly on the end of life cycle for the product. The expected result from the integration by ontology, LCA, LCC, and SLCA, the decision maker can use this integration to develop the product sustainability. Also, in three dimension, for the expected result, for example, will decrease the cost by using the material, the recycled material. Also will enhance or decrease the environment by using the green materials, green technology. Also for the social, there will be increase the social impacts, especially in develop or new job in the local community. Thank you very much.